Hey everyone, today we are going to solve LeetCode 2585 count the number of complete components. So basically the question goes like you are given an integer n, there is an undirected graph with n vertices numbered from 0 to n minus 1. You are given a 2D integer array edges where edge of I is equal to a comma b, means this is the edge from a to b, and as this is an undirected graph there is also edge from b to a, denoting the undirected edges connected vertices A and B. Return the number of complete component connected of graph. The complete components of a subgraph. Complete component is a subgraph of a graph in which there exists a path between any two vertices and no vertices of the subgraph share an edge with the vertices outside the subgraph. Is basically this is a definition of a connected graph. What it says that connected graph is the graph which it is a subgraph of a complete graph, and in that graph every two vertices are connected to each other, means we can traverse from one vertex to another vertex in that connected graph, and no vertex has a edge with the outside the component of the graph, right, of the subgraph. So as this is a complete graph, and there is also the complete graph connected is said to be complete if there exists an edge between every pair of its vertices. Okay, and basically there is also a definition of a complete graph like in complete graph, if there are n nodes, as it is the property of a complete graph, it says that if there are n nodes in the complete graph, so there must be n into n minus 1 divided by 2 edges. Okay, this is the property of a complete graph, as we can verify it also if there are three nodes. So basically 3 into 3 minus 1 divided by 2, so there are three edges. Okay, and you can try it with another graph also. So basically, this is the property of a complete graph, and this is the important property to solve this question. So basically, what we are supposed to do, we are supposed to have this subgraphs, okay, which is represented by these edges of 2D array integer list. Okay, then basically we have to find the complete component inside the list. So if we see, we will first make the adjacency list from these edges, and then traverse on the each and every node of the graph. If the graph, and call the DFS for each node. If the node is already visited, means it is in the same component. Otherwise, we will start the new DFS traversal, count number of nodes, number of edges present in that component, apply this condition, and just get the output. Okay, this is the higher level intuition of this problem. It is not that tough problem, but we will try to see how we can solve this one. So basically, what I am saying, I have to create first the adjacency list. So you should know that how to form an adjacency list. So basically, adjacency list is just a 2D vector representation of a graph in which we are supposed to see that a node, a particular node, means a zero node, is connected to which of the other nodes. It's basically in the adjacency list, if there is zero, so its connected component is 1 and 2. Okay, so uh, we will just form an adjacency list. So it is like we will iterate on the 2D integer array edges, and basically in the edges e of 0 dot push back e of 1, and adjacency of e of 1 dot push back e of 0. Why did I write this condition again? Because as there is mentioned in the question, it is an undirected graph, so there is also if there is edge from a to b, there should also be the edge from b to a. So that's why I have written this one. Okay, now nextly what I have to do, I have to find the connected component. Firstly, I will try it with DFS traversal, because DFS traversal is supposed to be a more ideal approach for this type of problem. We can solve it with DFS, BFS, union find, and there are multiple ways. If we have to use disjoint set union, the problem like this, we can use the disjoint set union, but if we can do it simply, then why we have to complicate the things? Okay, you should know the idea of the disjoint set union for this problem, but I don't think that you should uh, try to approach that DSU algorithm in interview if it is supposed to be solved by DFS and BFS. Okay, so let's try. with DFS1. Okay, so I will in count variable I will store the connected components inside this graph. Then next I will uh, traverse from uh, traverse to all the nodes. Means there are 6 nodes in the graph. I will check all the nodes. Okay, and keep a vector into visited node helps to find me out that whether this particular node is visited in another component or not. Okay, so it is basically like if there is no visited of I, then we are supposed to call the BFS traversal. In the DFS traversal, I will try to find the number of nodes, try to find number of edges. This DFS traversal will not return anything. It will just try to collect the information from that subcomponent of a subgraph of a graph. Okay. So basically, I will call the DFS with the particular node I, pass the adjacency list, pass the visited array, pass the node, and pass the edges. Okay. Uh, it is just a void return type, so it will not hamper anything. Now I will try to write a DFS function. Now, what is void DFS? DFS is basically simply we are calling the recursion again and again to traverse the graph, traverse on the adjacency edges or the adjacent nodes of the graph. So basically, it will like in you will write because node is already declared into you. Then there is supposed to be a adjacency list. Adjacency list. Okay. After the adjacency list, we have visited array, then node and edges. Why we are giving ampersand sign? Because we don't want to create new copy of that no edges or no. We just want that original node and increase that count only. So it will just ampersand means just referring to that particular address space, right? So we are not changing it. We are not duplicating it. We are just changing the same edges or nodes that we are passing from here. Okay. So now the base case of it's like visited of u is equal to 1. Okay. Now next, each time I call a DFS means I'm visiting a node, right? And what about edges? Should I do edges plus plus? Is it okay? Edges plus plus? I don't think so. Because if I'm here, this will call a DFS. Firstly, I will visit this node. So node plus plus edges plus plus. Okay. Means one node, one edge. Then I will go here. Then again node plus plus and edges plus plus. Edges plus only one plus means node 2 h2. Then I will go here. Node 3 h3. Okay. Node 3 edge will also get plus. The edge will also get 3. But are there 3 edges? No. There are 2 edges only. So we can't do this. Now then what we will do? So basically how am I supposed to traverse on another node? I will check the adjacency list. Traverse on the adjacency list. How will I into DFS? Like basically I will just walk of adjacency node on adjacency of node. Adjacency on node or adjacency of u. Okay. I will traverse on the adjacency list. Check the adjacent element. Just call the DFS. If no node is visited, obviously. No node visited. Adjacent node is not visited. So call adjacent node, adjacency list, visited array, node, edges. Okay. So if this is the case, then how am I supposed to find the edges? I'm supposed to find the edges by the adjacency list. Okay. How many edges are there in the graph? If you check 1, 2, 3, 4, 5. Are there 5 edges? Yeah. How many edges are there? 1, 2, 3, 4. Yeah, there are 4 edges. So I will just do adjacency of I will adjacency of u. dot size. Okay, so as this condition is done, then I will check this is the graph is complete one. So how will I check it? If edge is equal to node into node minus 1 divided by 2. Okay, if this is the case, then I will increase the component and that it is a complete component and just return my code. Okay, so this is the higher level intuition of this problem. Okay, now we will try to run this one. I guess it should pass. So let's see. It is giving some okay, passing here the size and the function parameter. It isn't good. Okay. Uh, Again, another issue. Okay, why am I keeping emphasis here? Okay, QWK. Okay, let's see what is the issue. I'm creating, yeah, good. Counting visited node, all DFS. DFS grab everything. And if I go here, I will count two edges. If I go here, I will count two edges. If I go here, I will count two edges. So yeah, as this is a undirected graph, so each edge is count as twice because one from A to B, one from B to A. So I have to reduce count of edges by two directly. Let's see now. Yeah, it is passing the sample disk. Now let's see. We are supposed to pass all the yeah. We are actually passing all the test cases. So basically, this question is like you should know what is a complete graph. You should know DFS traversal. That is all. Is good to go. In plus C, time complexity, and nodes plus T edges. Okay. So now, so now we will try to solve this by BFS. Some people thought that DFS is tough one because it use recursion, but it is not that tough. But let's try to solve it with the BFS also. So for BFS, what is the prerequisites? I should have a queue. Just two nodes. Okay. Then I will just remove this function calls. Okay. Now basically what will I do? If I get with a new component, I will just push that component into two mark the visited of this component as this and traverse on the queue until the queue gets empty. Okay. Pop the top element of the queue. So it is like into queue dot front and the queue dot. Okay. Then as it is the as we are storing the nodes in the queue, so each time we remove a node means we are visiting a node. Each time we remove a component from the queue means we are visiting a node, right? So this is dish, and then for edges, there is the same case. Okay. Edges adjacency of u dot size. Okay. Now we will traverse on the adjacency list. Adjacency node. Adjacency u. Uh, if not visited of adjacency of node, push it into the queue with adjacency node and visited of adjacency node is marked as one. Then here, yeah, we will just same do the same thing. Edges divide is equal to two because at as this is the undirected graph, right? Then if edges is equal to node into node minus 1 divided by 2, so count plus the return count. We are we should be able to pass this also, I guess. Yeah, submit. Okay. Sorry, mistyping. Let's see. Yeah, we are good to go. So basically, we have solved this question using two approach, BFS and DFS both. Okay. So yeah, this question is good if you to check the knowledge of how you know about graph, how do you know about the traversal method of the graph, how you can approach this type of question is good. We require the critical thinking for that. Okay. So yeah, uh, thank you for watching the video. Let's see you guys in the next one.